Here we are, ladies and gentlemen, for the Week 25 test. Now remember, these are the last new concepts that will appear on tests this year, and you'll have two more opportunities, one during Week 26, one during Week 27, to test on the Week 25 concepts, plus there are still intervention opportunities, so be sure you take advantage of those. Here we go with the Week 25 test. So on question 25-1, you are asked to make some kind of a list to show all the possibilities for Sophia, Natalie, and Matthias, who are the finalists in the school spelling bee. And they can finish in one of three places. So they're awarding prizes for first, second, and third. These are the only students left in the finals. There are three of them left in the finals. Here we are, Sophia, Natalie, and Matthias. And they are going to finish either first, second, or third. So here's my list. I created a list, and I did it in a really organized way. I started with Sophia, and I showed the two ways that Sophia could finish in first. She can finish first with Natalie second and Matthias third, or she can finish in first with Natalie third and Matthias second. Then I did Natalie in first. She can be first with Sophia second and Matthias third, or she can be first with Sophia third and Matthias second. And then finally I did Matthias finishing in first, and you'll notice she could be in first with Sophia second and Natalie third, or in first with Sophia third and Natalie second. That gave me this table, gave me my answer of 6 possibilities. And the last part of this table, it says, how many outcomes place Matthias in first place? Here's Matthias in first place right here. And that's 2 possible ways. So this would be a place where drawing one of those grids would not be a good choice. This list would be similar. Let me just show you really quickly. This list would be similar to creating a tree diagram. Here's a tree diagram. There is Sophia, finishing in first with Natalie second and Matthias third, or Sophia in first and Matthias second and Natalie third. And we could create the same kind of tree starting with Natalie and the same kind of tree starting with Matthias. Let's just finish that finish one leg of the Matthias tree. One leg of the Matthias tree would be Matthias in first, Sophia in second, Natalie in third. The other leg would have Natalie and then Sophia. All right, on to question number 2. So question number 2 works with this spinner. This is concept. Let me just stop the video right there. Concept 25-2. Let me scroll or just change the zoom on my screen a little bit, see if I can get the whole thing in here. Pretty close. So on this problem, we're using the spinner, and we're first asked, what's the chance that you would spin twice and get a 2 both times? We would say probability of a 2 and a 2. Well, the probability of getting 1 2, just spinning and getting a 2, right here, that probability is 1 out of 5. So it's also 1 out of 5 this time, which means the probability of getting a 2 and a 2, we multiply those 1 out of 5 times 1 out of 5 together, and we get 1 out of 25. Here's a table we had used in class to show why we end up multiplying together. There are 5 different options on this first one, and the probability of getting that 2 was 1 out of 5. There are 5 different options for the second, and the probability of getting that 2 was 1 out of 5. And we're getting the area, a 5 by 5 grid, so it has 25 squares in it all together, 25 sections. And we can see right here that only one of those sections is a 2 and a 2. So if we go back to our test, the shortcut for understanding how that works is to say we're going to multiply the probabilities. Part B, we run into the same thing. The question is, what's the probability that both spins are less than 4? So 2 spins that are less than 4. So the probability of less than 4 is 3 out of 5. There are all 3 of these on our spinner that are less than 4. So there's a 3 out of 5 chance. Since it's both less than 4, there's another 3 out of 5 chance. When we multiply those, 3 out of 5 times 3 out of 5, we get 9 out of 25. If we go back to our table, this is where we did it on the extra table that we looked at. Here is the section where both numbers are less than 4. If you get out here, you got a 5 and a 1. Part of it's less than 4, but not all of it. You get down here, you have a 3 and a 4. Again, part of it less than 4, but not all of it. Only in here do you get everything that's less than 4. So you get, for example, right here you get a 3 and a 3. Right here you get a 1 and a 2. And you can see that when we get that everything less than 4, we have 9 out of this whole big thing of 25. Our shortcut to doing that is to say multiply the probability of the first event by the probability of the second event to get the probability of them happening together. All right, on to question C. What's the probability that the sum of the 2 spins is greater than 6? So I made a table. Spins 1 through 5, spins 1 through 5, and looked at the sums. And here were the sums greater than 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places out of 25, or a 2 out of 5 probability of having both spins sum up or add up to a number greater than 6. On to the back of the page. And remember, at any point, you scroll this so you can see the whole problem again. At any point, rewind these, do whatever you need to do to help yourself be more successful with it. Okay, to the back. Our first problem on the back, spinner again. This time the spinner is not divided up evenly. You can see there are 1, 2, 3, 4, 5 blue out of these 8 slots. And they ask us to find the probabilities. Blue, 5 out of 8. Red, 1 out of 4, which was 2 out of 8. Yellow, 1 out of 8. Now, something we didn't touch on in class, if we take those 3 probabilities, 5 out of 8, and we add it to 2 out of 8, and we add it to 1 out of 8, since those are all the things that can happen, it's either blue, red, or yellow, we know that has to add up to 1 whole, which is 100%. Anytime you put in all the possibilities, you're going to get 100%. Then we were asked to move these to the number line. So the yellow at 1 out of 8 falls between 2 out of 8 and 0. This would be 0 out of 8, 1 out of 8, 2 out of 8. The red at 1/4, that is 2 out of 8, 25%. And the blue at 5/8, that's between the 4/8 and the 6/8. So Maria rolls a number cube 60 times. We're on question number 4 now. 60 times. Now, why they don't just say rolls a dice, I don't know, but rolls a number cube. How many times should she expect to roll a 6? Well, we can see that the probability of getting a 6 right here, the probability of getting a 6 is 1 out of 6. So we would expect that in 60 rolls, you should get a 6 10 times. If you want to think of the proportion to show that to yourself, there's the proportion. Here's the unknown. We don't know. That's the question. How many out of 60? You could cross multiply 6 times x and 1 times 60. You could say, I know that 6 times 10 makes 60, so 1 times 10 makes 10. However you do it, 10 times. For part B, what's the probability of rolling a number less than 5? So if you think the numbers less than 5 on a standard die, here are the numbers, 1, 2, 3 and 4, those are the numbers less than 5. So there are 4 out of 6 total. That's a probability of 2 out of 3. And if we're still doing our 60 rolls, we should expect that there would be 40 of those numbers, that 40 different times the die would come up with a number less than 5. On to number 5. So we are given 2 box and whisker plots. These are being used to compare 2 different classes of students and how far they walked during their walkathon fundraiser. The first class, you can see the student who walked the least walked 35 miles, and the student who walked the most walked 65 miles. We know that by looking at this minimum and this maximum. For class 2, the minimum student walked 20 miles and the maximum walked 70. Ready to answer our questions. Question 1. There is more variability, which means greater range, in the miles walked in class 2 than in class 1. Absolutely. The student who walked the least in class 2 walked 20. The student who walked the most walked 70. So there's 50 miles difference between the least and the most. In class 1, the student who walked the least was 35 and the most was 65, so there's only 30 miles difference. Letter B. 8 students in class 2 walked less than 30 miles last month. So we go to class 2. Let me get rid of some of the extra things that I've added. We go to class 2. Here's the 30-mile mark. These students, the students that go all the way from here to the minimum, represent 25% of the class. Every quartile is 25%. You can see I wrote it in class 1's boxes and on class 1's lines in blue. So 25% of the students walked less than 30 miles. 25% of 24, 25% of 24 is equal to 6, not to 8. So B is false. C. More students in class 2 walked more than 60 miles last month. This yellow line is where the 60-mile mark is. Now, some students said, I thought that was true because I was comparing it to class 1. Well, in class 1, 25% of the students walked more than 60 miles. In class 2, this whole line and the maximum are 25% of the students. So of that 25%, there were some below 60 and some above 60, whereas in class 1, they were all above 60. So C is false. D is also false. D is the opposite of A. There's more variability walked in class 1 than class 2. That is not true. All right, ladies and gentlemen, so items that are going to be on the test tomorrow. Remember these same concepts, not concept 23.1, but concepts 24 and 25 will be on the test for week 26. So be sure that you study those concepts and you feel super confident when you come into class for the week 26 test.